Dear participants, I am Tetiana Kril. Me and my colleague Iryna Cyerevko represent the National Academy of Science of Ukraine Institute of Geological Science and National Kyiv-Pechersk Historical Cultural Reserve. Our report is concerned with the risk of the soil foundation stability losses of the Kyiv-Pechersk Lavra Dormition Cathedral due to the urban activities. The territory of Kyiv-Pechersk Lavra National Reserve occupies a significant area and covers various geomorphological elements of the Dnieper slope in Kyiv. There are hazardous geological processes have become widespread. On this scheme, you see landslides, flooding, subsidence of lower soils, and other processes. They affect the technical conditions and preservation of architectural monuments. One of the attractions of the reserve is the Dormition Cathedral, a unique building of ancient architecture rebuilt in the forms of the 18th century. The building was undermined in 1941. The restoration of the cathedral began in 1996. The authentic strip foundation were strengthened with micropiles. The Dormition Cathedral is located on Upper Lavra, where spreading subsidence of lower soils, flooding by groundwater, and leaks of cold and hot water from water supply networks in the soil layers have affected the cathedral. In the slide, you see the results of those processes. On the walls of the basement, there are numerous traces of old wetting after repeated flooding, destruction of the paint and plaster layers. You see suffusion of soil removal on the floor. In the interiors of the northern part of the second tier of the cathedral, horizontal cracks recorded on walls along the perimeter, vertical structural cracks on slab and around the lowered arch. You see cracks also. The cracks opening is from 0.5 to 1.5 centimeters. Flooding of the basement occurred repeatedly as a result of surface runoff entering the cathedral due to the imperfect drainage system from the adjacent territory, in particular due to the abnormal rainfall. Future infiltration of water into the soil's mass led to the waterlogging of the lower soil layer, its subsidence, and as a consequence to uneven settlement of the foundation cathedral and the deterioration of the technical condition of the building. Therefore, the main purpose of the research was to calculate the stress-strain state of the soil foundation of the Dormition Cathedral and determine zones of plastic deformation and factors of deformation of structural elements. To achieve the goal, we use the schema of engineer protection of the territory, the plan of the current state of the reserve, data of engineering geological surveys, geodetic plans, data of engineering geological investigation, historical and archaeological materials. The numerical methods of finite elements analysis realized in Plaxis software and methods of statistical data analysis were used. You see the geological section diagram in the slide. It was used for the calculation. The physical and mechanical properties of each soil layer are in the table. There are layers like sandy loam, layers like loam, different type of sand layers, plastic sandy loam with layers of sand, and hard brown layers. The thickness of the subsidence lowest soils rise from 11 to 13 meters. The stress-strain state calculation was carried out in 4 stages. In the first stage, the soil mass is under the influence of loads from its own weight and from groundwater. The calculation type used is gravity loading. The second stage took into account the construction of foundation, first strip foundation and then micropiles. The type of calculation at this stage and subsequent ones is plastic. At the third stage, the load from the cathedral on the strip foundation elements was introduced into the calculation. And the fourth stage is modeling the flooding situation of the basement by specifying a band distributed load on the foundation slab from the weight of the water column. The displacement of the finite elements of the descent scheme are taken into account only after the fourth stage. You see the deformation grid of the soil massif after modeling. The maximum values value of 0.02 meters after the fourth stage. The deformations cover over entire pile field under the cathedral building, but don't reach the maximum allowed values. It's 8 centimeter by state construction standards. The diagram of the formation of plastic zones in the massif is shown in the lower figure. Red squares indicate areas of possible displacement, and cluster of white squares indicate plastic zones formed during tension. Additional displacement were generated in a separate calculation step. General displacement have no physical significance, but additional displacements as a last stage, especially during flooding, provide an indicator of likely mechanism and location of imbalance in soil mass and places in the structural elements where cracks should be expected to appear. Each stage of modeling shows an increase in deformations in the left part of the modeling. Under the basement of the cathedral, in particular after the flooding of the underground part. The curves in the lower figure on the slide show all 4 simulation stages for control points. You see here it. A decrease in the angle of curves in the last stage indicates an increase of plastic deformation. But the calculation results show that the soil mass remains stable at the end of this last stage. The modeling carried out indicates that plastic deformation of the foundation soils are still in the stage of incomplete stabilization. And the main risk of intensifying deformation at the present stage is waterlogging of the soil mass during as a result as groundwater levels growth or emergencies leaks. And conclusions. Dormition Cathedral of the Kyiv-Pechersk Lavra is located in complex engineering and geological conditions caused by the presence of subsidence loess soils, excessive overmastering of the soil base caused by deterioration of the technical condition of unique structures, such as uneven settlement, cracks, moisturizing of the basement walls, calculation of the stress strain state of the soil foundation of the Dormition Cathedral, and determination zones of plastic deformation using Plaxis software showed an increase in deformation in the northeast part, in particular for the scenario of flooding of the underground part. This is confirmed by the field observation. You see a photo in the first slides of vertical, horizontal structural cracks under the spring arch. Plastic deformation of foundation soils and, as a consequence, deformation of structural elements are still in the stage of incomplete stabilization, and the main risk of intensification of deformation may be the processes of overmastering of the soil mass as a result of natural rise in groundwater levels and the results of emergency leaks from hot and cold water networks. Reliable operation and prevention of cracks and deformation in structural elements must be ensured by improving the management of protection measures according to the researchers' building norms and standards. Measures to minimize the impact of man-made leaks should be aimed at the following: reconstruction of the water supply networks, current repairs with cracks injection, modeling the stress strain states of the structure, consolidation of lost soils, constant monitoring, including physical researches, implement in comprehensive system of tools for instrumental structural health monitoring of the reserve object into the existing monitoring system. I'm finished. Thank you for your attention.